Is a treatment for depression and post-traumatic stress disorder, PTSD, imminent? I think it is, for two reasons. One is very recent work in neuroscience, and the other is some psychology. I'd like to explain in this video why I think that's the case. Let's look at what psychiatry has been saying about the treatment of depression and PTSD for some time. And there's no better introduction to the subject, I think, than this book, The Body Keeps the Score. It goes through all the different treatments for PTSD and depression and what they are, what they do. It comes to some stunning conclusions. Link down below. Let me borrow some of what that book says about PTSD, for instance. Let's imagine a roadside bomb, a terrible event. A soldier is injured and he sees colleagues die. He suffers perhaps from PTSD. Every time he sees something related to the incident, directly related, like a picture of a soldier, maybe on TV, then he recalls that traumatic event. Every time he sees a fearful face, he recalls his face and his colleagues. He might pass someone in the street limping, some kind of injury, and that reminds him perhaps of his injury. And we go back to that event again. In fact, any type of injury may remind him, or a loud noise takes him back instantly to that landmine. Anything to do with hospitals, any mention of death, in fact, anything unexpected can trigger recall of that event, even if it seems an obscure connection somehow. He gets struck with emotions like fear, regret for not doing something, extreme sadness, and perhaps guilt about, who knows, leading his soldiers that way. So you see small triggers, and the man starts thinking about it over and over again. The pathways in his brain channel to that traumatic event to such an extent that he may never be able to forget it, or he may bury it in his conscious and becomes traumatized for reasons he doesn't understand. He blocks the memory of that event completely. This is possible. Okay, so a little bit of neuroscience. How does the brain work? Well, when a person is learning, when a person is developing long-term potentiation, nerves grow out and towards each other and form synapses. When a signal arises, one nerve might be the presynaptic neuron, and another nerve may pick up that signal, the postsynaptic neuron. So let's look at the specific case of serotonin. Serotonin is neurotransmitter transmitted from the presynaptic neurons to the postsynaptic neurons in some parts of the brain. And there are drugs that prevent the reuptake of serotonin. So there's excess serotonin in the junction, and they're called selective serotonin reuptake inhibitors, SSRIs. SSRIs are abundant. They're heavily prescribed. You probably know Prozac. At this stage, it seems clear that the SSRIs act at the serotonin receptor, but the breakthrough relates to another neurotransmitter. And this one is a growth hormone, a protein growth hormone called brain-derived neurotrophic factor. It's a growth hormone that we've been working on in our group for some time, and many people are. BDNF, brain-derived neurotrophic factor, interacts with TRK receptors and selectively for TRK-B. TRK-B is displayed on the surface of some neurons, particularly at the synaptic cleft. So let me revert back to our soldier. He's stuck in this loop of trigger, recall, response, generating anxiety, undesirable emotions. How do psychiatrists treat this type of problem? I'm not a psychiatrist, but I have a rough outline. First of all, they may use serotonin reuptake inhibitors, SSRIs, to block this channel. But people in psychiatry know that SSRIs are not always effective. And when they are effective, but the dosing is ceased, the patient can revert to his previous state. Treatment with SSRIs is most effective when it's given in conjunction with therapy, and even better, when given in conjunction with a change environment. If the soldier would move to a different location, perhaps make different friends, it gets his mind thinking about other things. The psychiatrist will try to get the soldier to think about other things, to recognize that this is just a memory, it's in the past. Now, the question is, most people think SSRIs are effective at the serotonin receptor. That's the state-of-the-art knowledge. But a recent paper implicates BDNF as having a much more serious role. And people have suspected this for some time because BDNF facilitates learning, long-term potentiation, LTP. We know that. And so if BDF can do that job, it can facilitate neural networks that bypass and branch out from the traumatic event. So it seems logical BDNF is involved. How might that be? Well, BDNF is involved in a lot of things. BDNF is a wonderful protein. You generate it in your brain right now. BDNF is found in regions of the brain associated with learning and memory. We generate BDNF when we exercise our brains. We generate BDNF when we have physical exercise. Indirectly, it makes us feel good. People who do fasting, I do 16-8 fasting. People who do this apparently generate more BDNF. So BDNF is like a lubricant for your brain. It helps develop new neural networks. I'd like to tell you about this paper in a very prestigious journal, Cell. Let me refer to this as the work of Carsten, the last author on the paper. In a previous video, which I produced recently, I went over the basics of cell signaling pathways. We have cell membrane, that's a transmembrane receptor, perhaps. It interacts with an exogenous protein, could be BDNF. And that brings two parts of the transmembrane together, perhaps in a dimer, not always. And when they are locked in this dimer, they initiate their own phosphorylation inside the cell, and that triggers a series of events, ultimately going to the nucleus. And the signal from BDNF might be, hey, neuron, grow out, divide even, regenerate neural cell. Here is a cell signaling pathway for BDNF. Oh, so intimidating. Look first at where BDNF is. Oh, look, it's associated with our friend dopamine. Dopamine is a feel-good chemical. Anticipation of something desirable gives dopamine in the synaptic cleft. And that stimulates the dopamine receptors, of course. And this affects LTP in different ways. If you want to understand more about cell signaling, I recommend this book. And I've left a link down below. There is some background that Carsten and his colleagues knew before they started the study. They knew at the tips of the synapses, at the synaptic cleft, cholesterol is found in a high concentration. They knew also that TrkB in its monomeric form is rapidly removed from the synaptic cleft. But TrkB dimerized is more stable there. And they knew of the existence of cholesterol binding domains, CBDs, in the transmembrane region of some receptors, like TrkB. But for TrkB itself, it wasn't known. So in a simple but beautiful piece of bioinformatics, they looked at the different TrkB receptors and found there is indeed a cholesterol binding domain only in TrkB, not even in its closest neighbors, TrkA and C. From that little piece of bioinformatics, they were able to speculate on what cholesterol does to TrkB. At optimum levels of cholesterol will bind to the TrkB receptor, and it stabilizes dimer formation in the active form so that BDNF can dock easily. And when it does, the signal persists at the cell surface, giving phosphorylation, and that neurite outgrowth signal towards the synapse is reinforced. And they proved this in a series of really elegant experiments. I'm just going to cherry pick one or two here. So first of all, they proved that in the presence of cholesterol at the synapse, there's more phosphorylation of TrkB on exposure to BDNF. But cholesterol alone doesn't give this effect. Cholesterol is behaving as a positive allosteric modulator by interacting with the cholesterol binding domain of TrkB. When cholesterol is captured around neurons by adding beta-cyclodextrin, the signaling goes down. In another experiment, a statin was added to neuron cells. You would expect the statin to depress cholesterol and therefore depress the outgrowth of these cells, and that's just what happened. And you can see it in these confocal microscope images. We see a neuron treated with actin, which shouldn't induce any outgrowth, and with BDNF under natural conditions, and BDNF gives outgrowth. But when the cells were treated with actin and a statin, there was very little outgrowth. And when the cells were treated with actin and BDNF, the outgrowth was suppressed. Exactly what you would expect. Very helpful in this study. They had mutants of TrkB expressed in another cell line, which cannot bind cholesterol. When they use those, they don't see cholesterol binding. They don't see the positive allosteric modulation, the PAM effect. Even though the mutated TrkB doesn't bind cholesterol, it will still bind BDNF, because BDNF binds in a different region. It's binding in the extracellular domain. The cholesterol is making the TrkB stay on the cell membrane for longer. It's stabilized there for receiving BDNF and then modulating its conformation to give intracellular phosphorylation. Carsten and colleagues also knew that certain antidepressants are known to interact with cholesterol binding domains in other receptor classes. So how about for TrkB? It's an obvious question then to ask. How about Prozac? How about ketamine? So in this Cell paper, they found the binding affinity of cholesterol, not very strong binding, but there's a lot of cholesterol around. And then they looked at the binding of Prozac to the same site. And they find that Prozac binds more strongly. And ketamine also binds more strongly than cholesterol. Prozac and ketamine will outcompete cholesterol at similar concentrations. In another experiment, Carsten and his colleagues photobleached away fluorescently labeled TrkB in neurons and looked at the rate of recovery of truck B, fluorescently labeled, after that. And what they find is you can actually see trafficking of the truck B out to the dendritic spine. There were many other experiments in that paper that prove cholesterol and antidepressants both act as partial allosteric modulators of truck B activity. When this video was almost finished, another paper appeared from Carsten. This one talks about a receptor for the neurotrophins called P75. In some situations, P75 can activate the neurotrophin receptors. That was known, but it turns out that P75 also has a cholesterol binding domain. That makes the story even more interesting. When a psychiatrist then prescribes SSRIs, the drug is not simply influencing the serotonin pathway, it's also influencing the BDNF pathway. What does that mean in the treatment of PTSD and depression? It means that with therapy, it's BDNF which is implicated in growing alternative neural networks. And we can rationalize that now. And in an environment change, it's BDNF again that facilitates the outgrowth of alternative neural networks. These SSRIs not only binding at the serotonin receptors, but also the cholesterol binding domain of TrkB and acting as a PAM, a positive allosteric modulator. Remember, the trigger, recall, effect sequence and how we propose treatment with SSRIs is more effective when therapy or a change of environment occurs at the same time. Can we rationalize now the role of BDNF in these two things? Well, yes, of course, because BDNF promotes formation of neural networks. And with environment change or therapy, the neural networks can be induced to grow out and avoid triggering this traumatic event. Up to there, the story is first rate, but it gets even better because van der Kolk and others have been arguing for some time, a very long time, in fact, dating back to evidence originating in the 1960s, that psychedelics can be used to treat these conditions. Psychedelics like LSD or psilocybin is a program for psilocin, PSI, it's called in this study. So in Nature Neuroscience, Carsten goes on to investigate this. Just in passing, let me note, isn't it beautiful, isn't it wonderful how compounds like LSD and PSI, which give this psychedelic effect, are effective at the serotonin receptors? Well, the analogy between serotonin and those two compounds is striking. Organic chemistry structures sometimes don't repeat themselves, but they rhyme. Carsten and his team went ahead and repeated the same types of experiments and some more clever in vivo studies too. And what they found is LSD in particular binds the cholesterol binding domain, the CBD, in the TrkB transmembrane domain 1,000 times more strongly than Prozac. And that rationalizes why some people say a single dose of LSD can be extremely effective for treating people with depression and PTSD. Well, a lot of neuroscience is covered in these two wonderful papers. And if you're a scientist, I recommend you go ahead and read them. But what about the psychology? How does that come into the story? Drugs in the United States must be approved by the Federal Drug Administration, the FDA. And ultimately, that decision comes down to a committee of around about 12 people. These 12 scientists don't like witchcraft. They don't like to prove things that they don't understand. So, for instance, ecstasy, NMDA, is known to be effective, but no mechanism was known. So the FDA met last year and said further research was required on this drug. I think this is because the FDA recognizes that these compounds can be effective, but they don't know how. They need a mechanism to scientifically justify approval. Similarly, LSD has been given breakthrough status too, but the mechanism wasn't there pre-Carsten's work. Carsten's work provides the rationale. It tells us why LSD should be so effective for PTSD and depression. I think now when the FDA considers the data again, in the light of this mechanism, binding of LSD to the cholesterol binding domain in the CBDs of truck B, it's got a much better chance of being approved because the psychology of the FDA reviewers should change if they're aware of this rationale. This, ladies and gentlemen, is extremely exciting. My money is on LSD being approved for this application under controlled setting. Thank you very much for listening. Bye-bye.
Picture yourself in a boat on a river with tender trees and mama-led skies. Somebody calls you, you answer quite slowly. A girl with kaleidoscope eyes. Xylophone flowers of yellow and green towering over your head. Look for the girl with the sun in her eyes and she's gone.
Lucy in the sky with diamonds. Lucy in the sky with diamonds. Lucy in the sky with diamonds. Sorry. Are we done then?